modulus function inequation, we will be solving the problems of inequations involving the modulus function. Firstly, we understand the basic definition of modulus function. Modulus x is there. The meaning of this is positive x if x is greater than 0, is negative x if x is less than 0. You can just write greater than equal to and here less than 0. Suppose one more example, modulus of x minus 2 is there. We will write it as x minus 2 positive sign if x is greater than equal to 2. You are just finding the critical point here. Here the critical point was 0, so x minus 0 was there. What is critical point? X minus 2. You just find the critical point like this. So critical point is coming out to be 2. So the sign scheme will revolve around x equal to 2. If x is greater than equal to 2, this will be positive. If it is less than 2, it will be negative. This is the basic definition of modulus function. We will solve modulus function inequations. So it is clear now? Very simple example I am taking. X minus 2 modulus is greater than equal to 2, like this. You have to get rid of this sign. So firstly decide the critical point. Critical point is 2 here. So sign will be dependent on whether it is to the leftward side of 2 or rightward side of 2. We will take it when case 1 I am taking. You just make a habit writing in this fashion. Case 1. When x is greater than equal to 2. So this is positive. So what is the inequation coming out to be? X minus 2 positive greater than equal to 2. So x is greater than equal to 4. We have to combine the two things, what we have assumed and what we have got. According to our assumption that x should be greater than equal to 2, and ultimately we are getting x is greater than equal to 4. So combining both the solution, if x is greater than equal to 4, this is satisfying both the conditions. So the answer solution of that case is this. Case number 2, I am taking case 2 when x is less than 2. So the thing is coming like minus of x minus 2 is greater than equal to 2. So all the time I am saying you get rid of this modulus sign with proper case identification. So it is coming out to be minus x plus 2 is greater than equal to 2. So it is coming x is less than equal to 0. This is because 2 is getting cancelled, x is greater than 0, minus x is greater, so x has to be less than 0. Now we have to combine the assumption and what we are getting. Our assumption is x should be less than 2 and we are getting x should be less than equal to 0. So the common answer to both the condition will be x should be less than equal to 0. This is the solution for case number 2. Hope you are understanding easy modulus inequation. Now I am taking one complex example of modulus inequation. If I am taking x minus 2 modulus plus modulus x plus modulus x minus 3 is greater than equal to 6, like this. So here 3 modulus signs are there and the critical points will be 0 for this, 2 for this and 3 for this. Be careful that if x plus 2 is there, then the critical point will be minus 2. I'm taking like this. You will see the case this also. So the critical point is now, if I'm taking like this, -2, 0 and 3. Now we have to revolve our cases around these critical points. Case 1 I am taking. Either the smallest thing is -2. When x is less than equal to -2, what it is coming out to be? It is less than equal to -2. This is negative, this is negative, and this is negative. So what we are getting? Minus of x plus 2, minus of x, minus of x minus 3. If you are finding a difficulty in taking the sign, see here, I am just giving you a small technique. You take something smaller than -2 and see whether the result inside is negative or positive for this. Suppose smaller than -2, I am taking -3. What is this? Negative. What is this? Negative. What is this? This is again negative. -3, -3, -6. So this is the solution. On solving this, it will be -x, -2, -x, -x plus 3 greater than equal to 6. So what we are getting? -3x. This is what? Plus 1. So it is greater than equal to 5. So we can say x is less than equal to -5/3. What is that? That is equivalent to 1.66 like this, minus of this. Our assumption was that x should be less than equal to -2, and what answer we are getting? X is less than equal to -1.6. So on combining the two things, the solution is coming out to be x is less than equal to -2. If x is less than equal to -2, it will satisfy this condition and this condition also. So for case 1, the solution is this. Now I am taking case number 2. In case number 2, I have considered the critical point -2 less than -2. So now I will take the critical point as x is greater than -2 but less than 0. So between -2 and 0, between these 2 points, firstly I take the interval this. Now we are taking this interval, then we will take this interval, and lastly we'll take this interval. Okay, be careful. So case number 2 is this. Between, it is greater than -2, so it will be positive. This is negative. Again you apply that technique that x is between -2 and 0. You take something between this. If you take -1, this is positive, this is negative, this is negative. Very easy technique I am giving you. So this is negative, greater than equal to 6. On solving, it is coming out to be 2 x is getting cancelled. -3 minus x is greater than equal to 6. So we can write -x is greater than equal to 7, because -1 is here and it is coming out to 7. So x is less than equal to -7. See, our assumption was that x should be greater than -2 and less than x. But here the solution we are getting, x should be less than equal to -7. So it is actually contradicting our assumption. According to that, x should be between this, and according to the solution, x should be less than -7. So the contradiction is there. So in that case, you just write no solution. Take this case carefully, that these two things are not matching. So solution is not in the interval. Now I am taking the third case. What will be the third case? You see here that it should be in this area between 0 and 3. If you take x is greater than equal to 0 but less than equal to 3, in this area I am taking. This is positive, see case number 3. X plus 2 positive, x is positive, but this x minus 3 is negative. So this is coming out to be, see here, 2x minus x, just x is there, 2 plus 3, the 5 is there, greater than equal to 6, x is greater than equal to 1. Our assumption was that it should be between 0 and 3, and here it is that it should be greater than x. If we combine these two solutions, a solution is there that x should be greater than equal to 1 but less than equal to 3. So this is the solution in case number 3. Clearly understand, we are just combining the two solutions and writing the equivalent solution of this thing. And the last case now we are taking x is greater than equal to 3. Case number 4, x is greater than equal to 3. So it will be positive. This is positive. This is positive. Everything is positive, greater than equal to 6. So 3x, and this is minus 1 is greater than equal to 6. So x is greater than equal to 7 by 3. What is that? 2.33, like this. Okay. See, our assumption was that x should be greater than equal to 3, and here we are getting x should be greater than 2.3. So what solution which is common to both we have to take is that x should be greater than equal to 3, which will satisfy both our assumption and the thing what we are getting. Hope you are understanding the inequation involving the modulus function very clearly.